Hello, everyone, and welcome to this Telit Cinterion webinar, 5G Fixed Wireless Access, RedCap, and Network Slicing, Transforming Connectivity. I'm Amanda Flink, the head of global events here at Telit Cinterion, and I will be moderating today's event. To explain this topic today, I am pleased to be joined by two speakers. First, we have Safi Khan, Technical Sales Director at Telit Cinterion. And second, we have Stan Gray, Senior Vice President of IoT Broadband High-Cat Sales at Telit Cinterion. Now, just before I hand it over to start the presentation, I do have just a few quick reminders for our audience. Please be sure to check out the resources section for some additional information on our topic. There you can find today's slide deck and a few other resources that will be mentioned in our presentation today. And also, we will send out this replay link to all attendees at the conclusion of the webinar. So be sure to check your inboxes in the coming days for that. And with that, Safi, I will hand it over to you to start our presentation today.
Thank you, Amanda. Hello, everyone. My name is Safi Khan, and I'm very happy to talk about 5G today. We picked these three topics as relevant issues that have been the topic of discussion for release 17 of 3GPP. And so, starting with just a little background and as to why IoT is so important, this is a little marketing insight that we have where, as you can see, 30 billion devices will be online this year. And that's a huge number. And this is a mix of connectivity options where some of them may be very low power, low data rate devices, but a growing number of devices are using the very high speed 5G technology that can reach multi gigabits per second, downlink speeds, as well as very, very high uplink speeds. So we will be talking about these devices today and how Telit Cinterion is at the forefront. We help connect these devices through cellular modules, and we also help manage them through our MVNO network with Telit SIM cards. And for us, we are basically seeing 1 million new IoT devices every week that basically need to be managed or added to the network. So let's get started. We will talk about the three topics in sequence today. So the first topic that we have is going to be the fixed wireless access. And as you know, in 5G, it's a new radio, it's a new physical layer. So it brings a lot of advancements over 4G as shown here. So the first one is flexible usage. So one of the things that happened is that the network became more virtualized, which means that you could now manage the network through modular approach where instead of the central unit of networking in the core of the past, the new 5G radios and 5G network architecture allows virtualization, network slicing, and the service offering can be very flexible. It can be managed more from the cloud with open ran and many new initiatives like that. And all that does is makes the software be the place where the innovation takes place instead of dedicated hardware, which was harder to change and upgrade, and everything is done easier in software. The second thing is flexibility of how you use the resources and how you scale them. So in 5G, you can handle a lot more number of devices. So it's highly scalable for massive IoT, and that is because the nomenclature of the physical layer has been extended to support devices that have very little data to send or receive, all the way up to the heavy duty devices that have a lot of data to send and receive. And as you know, 4G, a lot of companies, operators, the industry invested billions of dollars in 4G. So the flexible architecture allows leveraging all of the 4G assets and combining them with 5G, where There is interworking and dual connectivity offering in 5G. So it can work side by side with 4G to really get the best of both networks. But also moving forward, 5G standalone is becoming another architecture that helps bring all the new innovations to the market as a 5G standalone core. So this is showing basically how the two axes are evolving in different directions. So on the vertical, as you can see, and as I mentioned before, the core network is evolving from the legacy architecture, and then on the horizontal axis, the radio itself is also expanding by using new spectrum, which we will talk about coming up, an extended RF subsystem. So the devices are more sophisticated in terms of the radio and the modulation schemes and things like that that they can leverage, and a better use of the resources. So there's a key metric in digital communications, which is how efficiently you use the megahertz of the bandwidth by sending reliable bits over the air. So in expanding both of these axes, the 5G evolution and revolution is happening. So first up is FWA, or fixed wireless access. So what is it? The way we define fixed wireless access is essentially high speed internet to your home coming over a 5G wireless connection instead of the traditional cable network or the fiber that the ISP or internet service provider sends to your home. And so this is a new business, a new technology innovation, and it is only made possible because 5G can achieve the speeds of broadband in a wireless setting. Because in the wired setting, there is a dedicated rollout, there is fiber and cable to be dug up into the trenches, and new homes need to have all that infrastructure spending done to get that internet connection to your home. Whereas for a wireless operator like the big MNOs, all they have to do is ship you a box to your home that basically has a Wi-Fi has a 5G modem inside. For example, one from Telit Cinterion, and you turn it on. It makes a connection to the cellular network, and then it has an Ethernet port where you connect your, let's say, Wi-Fi router, and after that you have the same broadband experience in your home, but it's coming through wireless. So the benefit is that no one has to dig the fiber and the cable. It's all done wirelessly.
I would add that even terrestrial based operators are able to deploy 5G fixed wireless access as part of their service offering. And that, that's good for us because it gives us choice. And it's good for MNOs or for network operators because it extends their reach nationwide, whereas they may have been a regional operator in the past.
Yes, very good point, Stan. Thanks. So then now that you understand what FWA is, let's get into the nuts and bolts of why and how it's made possible. So this slide is actually showing a lot of aspects of the 5G network that come into play, specifically how 5G achieves the higher performance that makes FWA possible. So on the left side, you have the 5G scope, which is the type of services and the performance and the new spectrum we will talk about. Then the implementation in the core network, which is the virtualization architecture, the resources, and the technology interworking. So all of these, if you see them mapped over to the right, it's specifically focusing on the performance aspect. And the chart shows that IMT Advanced, IMT 2020, this is basically coming from the ITU, which is the International Telecommunications Union, and it's basically mapping the efficiency of the technology at the different aspects. So as you can see, the bigger your circle, or the further out you are, the more higher you are in performance. So if I look at area traffic capacity, for example, on the top, on the top left side, you can see megabits per second per meter squared. And so that shows that, when you reach that higher level of coverage, it's better than the previous generations. And moving along the same loop, if you go to the other performance spectrum, performance metrics, you can see spectrum efficiency is 3x. So that's basically, spectrum is the very precious resource which is governed by the FCC, and the more efficiently you can use the spectrum, the more data the more capacity you have in your network. So basically, because of all the advancements in the standard, in a nutshell, 5G outperforms all of the previous technologies. And because of reaching that multi-gigabit per second throughput uh, milestone, we are able to talk about FWA. So let's focus a little bit on the spectrum aspect, because this is one of the key things that really drives the increase in performance. The boost you get is from spectrum. So traditionally in 4G, the spectrum was below sub gigahertz, sub 6 gigahertz. And in technical terms, that was called FR1, or as shown here, frequency range 1. However, the FCC also opened up a new spectrum called FR2, which is called millimeter wave. And this is spectrum in the much higher band. So FR1 is below 6 gigahertz, but FR2 is somewhere in the region of 25 to 30 gigahertz. And the amount of spectrum available in FR2 is much higher because it was not used previously. However, FR2 comes with a lot of technical challenges. And so we will talk about the mix between these two. And even within FR1, 5G opened up some new spectrum bands, which are really at a sweet spot where you get a wide spectrum, but it comes in the band which is easier to propagate. So if we get into very technical details, which we don't have time today, you would understand that the physics laws let the FR1 waves propagate much faster, much further out, and also easily through multiple walls or obstructions. But FR2 really almost needs a line of sight to the base station, and has a lot of requirements in terms of propagation. So it doesn't travel that far. So because of that, the 5G network system leverages new spectrum, which is allowing the radios to have higher speeds. So this one is explaining what I was saying about FR1 and FR2. So in FR1, today we will focus a little bit more on this frequency range, where you can see that the C band, which is really the new bands that the FCC auctioned, is in the sweet spot. Why? Because it's in the lower band, so you have best coverage, but it's wide enough that it allows the modem to be able to send and receive data at a much higher speed. So it boosts the performance compared to 4G. And of course, when we go to FR2, of course, the cost of the modem goes up, and the deployment challenges for the operators are there because they need to have lots of small cells where there's a line of sight to the devices. So FR2 is very good for hotspots like stadiums or venues where there's a campus or many people need like a dense area, and they can do a special deployments there in 5G FR2. But for fixed wireless access coming to the homes or enterprises, FR1 is the technology of choice. It's more cost effective, and yet it has the high throughput. Okay, so I'll hand it over to Stan to really talk more about the business aspects of the use cases of 5G FWA.
Thank you, Safi. So, the use cases for fixed wireless access are really wired connection replacement. So, think of unconnected homes or wired connection replacement, as I mentioned before, where you may be working with a terrestrial based network operator who now has the ability to provide a 5G non-wired solution. Small and medium business and secondary homes, cottages, those kinds of things. The other use case is backup and failover for traditional wired connections. So things like environmental disasters or during storms when the terrestrial connection may go down. If you're running a branch office or a bank, you need to have constant connectivity, and a fixed wireless access device, failover device, would help you through that. Easy and quick deployment at local construction sites. Cuts, it makes deployment easy, as well as if a cut is made to the main line and a particular part of the city is out, then you have that ability to deploy a 5G fixed wireless access device. It does enable some interesting use cases like mobile command for public safety or locations where pulling cables is not practical. And I'll hand it back to Safi.
Okay, thanks, Stan. So moving along, just to close up the FWA section, basically we have pretty much given you the story about fixed wireless access, but in closing, the features and benefits of FWA are there for customers to leverage. It's basically enhanced mobile broadband, which was the original promise of 5G. And in fact, data suggests, as shown on the second bullet here, that there's already 121 service providers offering this FWA over 5G, and that is almost half of all the FWA providers. And total connections are expected to reach 330 million by 2029. So this is a projection by the Ericsson's mobility report of 2024. So this is very real. It's happening, and it's going to make it easier to provide connectivity, also bridge the basically the digital divide, where you may have areas which are not served by other means, so you can reach untapped markets with FWA, and it's basically a better use of the spectrum. So basically, what I would close with on this section is to highlight some of Telit Cinterion's 5G products, which are enhanced mobile broadband ready and can be put into routers, gateways, customer equipment, any kind of an internet appliance that needs a backup failover protection from the main broadband connection. So those are some of the industrial or enterprise use cases that we play in. So coming up, shown up here on the left side is our latest product lineup. So release 17 based products, and we have a global M.2, which is the FN990B. It's based on a Qualcomm chipset, and it's a M.2 form factor, full industrial temperature range, and it's a sub 6, which is the FR1. And below that is the FE990B series. So these are in the LGA package, and these have the capability to basically provide an integrated brains of a device that can run hostless, which means there is no additional host CPU required. All of the OS and all of the routing and networking functions can basically be run on the quad core processor already inside this modem. So this is our latest product, and we already have samples, and you can click on the resources to see how you can get access to the information about this product. The next one I want to talk about is the one on the right, which is release 16. So these are already in mass production. These are based on release 16 chipsets, and they're already in the market with actual customer devices. So they're shipping. And similar feature set, they're global M.2 cards, and they do require an external host. And they're based on the SDX 62 and 65 from Qualcomm. And finally, in the middle is what we will talk about in another section, which is the Release 17 RedCap products. RedCap stands for Reduced Capability. So we'll talk about that coming up next. So I won't touch on it too much here. But with that, let's move on to our next section. Okay, so now we will talk about 5G RedCap. And this is a new technology which is basically an abbreviation of reduced capability 5G. And the first devices that came out of the 5G ecosystem were enhanced mobile broadband, which basically allowed the fixed wireless access type of technology to take place. However, they required high performance, high power consumption. They required four antennas, and you had very high speed data. However, 5G is also a scalable technology, and so RedCap was born out of the idea that there should also be the reduced capability 5G that can serve the market that cannot afford to pay the high price and doesn't need the high data rate of the mobile broadband version of 5G. So this is a first 5G standalone only technology, which means there is no connection to 4G. It is all purely running on a 5G radio and connects to a 5G core network. And it basically is being rolled out in the North America as the first region where RedCap will be deployed. And since it's a new technology, it is more power efficient than the 4G variant. It's equivalent to the LTE 4G Cat 4 with some additional features, which we will talk about. And it supports a 4G fallback from a chipset perspective. So as 5G RedCap starts getting deployed, it may not be available in all the places in the beginning. So the modem will have a capability to fall back to 4G in the cases where 5G signal is not found. And in terms of the market, it will serve many use cases in industrial IoT, which Stan will cover. So let me talk a little bit more about the market and the positioning of RedCap. This is a research report from Omdia that's saying that if you look at the color coding, the yellow on the top is the growth shown for 5G RedCap. So 5G overall is the green plus the yellow, and the blue is the 4G. So as you can see, all the way up to 2026, 4G connections will be increasing. But eventually, starting at 2027, there will be more newer 5G connections than 4G connections, which is not to say that 4G is going away anytime soon, but it's just showing the trend that 5G will start being more and more preferred by customers because of the new features introduced by RedCap as well as the 5G mobile broadband. Now, we created this chart to illustrate the different use cases of the market for IoT and how the different aspects of 5G fit in. So, in release 17, the RedCap that is defined, it's really a mid-speed technology because there is another technology below it, which is the low power wide area, LPWA, which you might remember as CAT-M or NB-IoT. That's not the topic of today's webinar, but it is another technology which is low power and very low data rates. So above that is LTE Cat 4 and Cat 1, and that is what the RedCap addresses. So this portion in the middle, which is the light blue, is the area of the 5G RedCap. It shows a lot of the different industry verticals like smart home, health, alarm panels, industrial cameras, maybe not very high resolution, but regular low resolution industrial cameras, looking for, let's say, defects in manufacturing and things like that. So on. So that's where RedCap fits in. And if you really talk about RedCap's evolution, there will be a release 18 version of RedCap, which will be even more simplified than the release 17 RedCap. But today we are focusing more on the release 17 RedCap. Now, as far as how it differentiates with the release 18 RedCap, this captures kind of a more of a side-by-side comparison. So within the mid speed, the left side of the blue shape is the release 17 RedCap, and the right side would be sorry, the right side is the release 17 RedCap, and the left side would be the next generation release 18. So release 18 is not here yet. It's still 2-3 years out, and it will be even lower speed than the release 17 RedCap. It'll be more closer to LTE Cat 1. So today we will focus more on RedCap release 17, which is really a Cat 4 equivalent. So the throughput is about 200 megabits per second in downlink and 100 megabits uplink. It is defined for a 20 megahertz channel for FR1, which is of the most interest, although it is defined for FR2 as well. And single antenna operation can be possible. So remember, I said earlier that the mobile broadband needs 4 antennas, but a RedCap device can be built with 1 or 2 antennas. So that simplifies the type of products that RedCap will target. There is no carrier aggregation, so it's a single CA, and it does require a 5G standalone network. And there are many power saving options. So it is more efficient for battery powered devices as well. So that will come up in the different use cases that Stan will cover. Again, to kind of just relatively compare the different technologies, the 5G mobile broadband, starting in release 15 and 16, had uh, two and four way MIMO, which is multiple input, multiple output. That's how we combine the different streams to get the boost in the speed. And in release 16, there was even more carrier aggregation as well as MIMO combinations, and it keeps going up as the releases come out. But down below for 5G NR RedCap, you basically have two receive antennas and only one transmit antenna. And so you can do MIMO on the receive 2x2 MIMO, but there is no capability to do 4x4 MIMO. And so it's limited in terms of its speed, but that also gives it the lower cost and the efficiency and the power saving features. So in a nutshell, that's basically RedCap. In the resources section, you will have two tables that compare the RedCap technical specs versus all the other LTE technologies below it and above it. So I highly recommend that you refer to the resources section and download the comparison of RedCap with other technologies. So I think with that, my section is over, and I will then hand it over to Stan to basically close out the RedCap use case.
Yes, RedCap. So a couple of things. If you kind of think back to the bar chart that Safi had shown, where 5G is growing and 4G is sort of on a bit of a slow decline. there is a lot of use cases that are built into 4G and will continue to operate in 4G. Things like consumer alarms and smart homes and things of that nature. But what RedCap and 5G are bringing to the world is really an expansion of the pie. So new use cases that require low latency, better power efficiency, or higher bandwidth. RedCap certainly enables those things. Things like body worn cameras that you will see on public safety, first responders. They require the low latency, and they'll broadcast this live sometimes. Sometimes it'll store locally, and it will download once they're back to the station. But oftentimes, as I mentioned, it's requires that they broadcast it live. RedCap does give the first responders that 4G backup, and it's in a very small form factor in comparison to a full-on mobile broadband 5G device. It's enabling new use cases like video telematics or alarm systems for buildings, remote patient monitoring, and this is kind of an interesting but growing field, precision farming, where there's a lot of intelligence built into how farmers actually plow their fields or seed their fields, oftentimes autonomously. And 5G certainly brings the capability to better deliver in the farming sector. And of course, renewable energy. From a private 5G perspective, POTS replacement is really becoming a big factor. So that's poor old telephone system, and that those analog or old systems are being replaced with wireless technology, and RedCap is really a suitable product for that. Private 5G in mining has been around for a while now, and in port data communications, like big shipping ports. And then finally, another growing area is connected machinery, where you have smart machines talking to smart machines within the walls of a factory. And that way you create a smart factory environment on a private and secure 5G network.
Thank you, Stan.
Yep. Go ahead, Safi.
Yeah, so basically, to summarize, we talked about the use cases, we talked about the technology, we talked about what RedCap is and how it differentiates itself from the mobile broadband version of 5G mobile broadband. So the key thing here is the SA network. And if you look at the roadmaps and see the press about SA networks in North America, all of the three major carriers are planning to launch. Some have already launched, some are in the process of launching SA networks. So in the long term, the 5G standalone network will be robust and be ubiquitous. So it will basically, wherever you have 4G today, you will have a 5G SA network there. So eventually RedCap will blanket the coverage throughout, and we from Telit Cinterion are again at the leading edge. So for the RedCap now, going back to our product lineup, we have some very exciting new products that are sampling already and very close to just getting certified as soon as the RedCap networks certifications process completes. We will be able to offer a M.2 global data card, which is called the FN920C04. This is based on another Qualcomm chipset, which is called SDX35. This is a smaller M.2 size than the one that I showed earlier. So this is a 30 by 42 millimeters. It's compact and it requires only two antennas for the cellular. It does have GNSS capability as well, which is locationing, positioning. And with the same chipset, we have a family for LGA. So we have the 910 form factor, which gives continuity to our customers to upgrade their 4G or even 3G or 2G products to 5G using the same pin out. And so the FE910C04 is a global LGA that brings out more interfaces, more peripheral pins, and can be an upgrade path for all of the existing designs with minimal changes. So this lineup of RedCap products promises a good entry into the market, and we are seeing very strong demand for these from many customers in the different verticals that Stan talked about. So RedCap is a new exciting 5G technology coming soon. So look out for that. And so with that, we close the second section of our webinar and move on to our last section, which is 5G network slicing. Okay, so our last section today for 5G nuances is 5G network slicing. And this may be new to some of you. You may know some things about that. But today we will explain what network slicing is and what are its benefits and use cases. So, in a nutshell, if you remember in the very beginning when we introduced 5G, we said that one of the things that they did in the standard is to virtualize a lot of the functions, which means that the function could be running in a cloud on a server, but it's really implementing the function of a network. So what happens is that now what you could do is with the power of software, you could basically run multiple virtual networks on one 5G physical infrastructure. So there are two main parts to a cellular network. So there is the radio and the infrastructure, like the hard assets that actually transmit, receive waveforms, and connect the towers to each other or back to the central core network. So that's the physical infrastructure. But then there is the virtual network that basically does the policy, the security, the SIM authentication, the service layers. So that's the virtual part of it. So the innovation of network slicing does is that you can now have a slice of that full. You can imagine the full network, but now you can cut it up into different slices and have each slice operate as an independent end-to-end network because now you have control over the virtualization. And so in a container, a software container in a server, you can have the entire network defined. But in another container right next to it, in the same CPU, you can have another instantiation of the network. And both of these could then point to one physical infrastructure. So now you could have two, three, four, up to however many slices available. But why do this slicing? The reason is that it can be cost effective in providing the different levels of service. So sometimes we want to give higher priority to some services versus other services. So the resources of the network can be optimized. And so data that is not urgent can be sent, let's say, at nighttime when the peak is not there. But if there is a mission critical data that needs to go right away, that can be prioritized and sent immediately. And that's what we will talk about. So, cost effective, flexible deployment. So, it means streamlining the network and boosting the network efficiency. And then prioritize service for mission critical applications. So, basically, have a dynamic control over who gets to go first. Back to the old drawing that we showed before. So, in the virtualization slice, what you see here is that network slicing enables multiple separate end-to-end networks sharing the same or using separate infrastructure. So here is illustrated by, let's say, 5 slices. So you could have the enhanced mobile broadband slice, and this SST is the slice type. This is a field inside the network, how you configure the slice. So then that could be one slice. The second one could be URLLC. Now that's a mouthful of an acronym, but it's ultra reliable low latency communications. So imagine autonomous driving, for example, that needs very, very low latency, immediate responses from the network to control autonomous driving cars. Let's say they reach an intersection and it's imagined that they need to coordinate with each other over cellular, then that could be one slice where you need something like that. Or another setting could be an industrial operation in a factory warehouse. So you have machines, robots, all running together, and they all have to be coordinated. And you always have the emergency stop button, and all of that becoming wireless using 5G makes it that much more efficient. So the network has to be very, very low latency. So that slice could have the highest priority, for example. Then you have the massive IoT, and this could be everything like the agriculture example that Stan gave, or automatic meter readers, for example, or anything else which is out there that's part of IoT, connected IoT. V2X, that's basically autonomous vehicles also. It could have its own slice where the traffic signals are coordinating with the lights and with the cars, and that has another slice. And then depending on the needs, you could have custom slices as needed. So this is what we mean by slicing, which is it's the same physical infrastructure, but the slice has a different personality. So basically, the underlying, um, I would say, the agreement or the promise is basically driven by the service level agreement. So in this case, the operator is going to sign up a contract with a customer and have an SLA. This SLA will guarantee, for example, a level of reliability that, okay, for this many nines, like 99.99% of the time, we will be able to service your devices in this much amount of time. And how they achieve that is, again, by the same example, having network slices and then charging the customer for each slice differently, as defined by the customer. So that's how slicing works. We have a couple of more examples to illustrate how that works. And so for example, the first picture on the top left is basically everything going through one EMBB slice. So from the end device back to the network or the cloud, all the different service layers are treated equally. They are different because they are different type of traffic. There's IMS traffic, internet traffic, and everything else. So the user plane traffic. So all of that traffic is going through the core and the network as one slice. And then the one on the right side is now saying that I have 3 slices where I have uh, basically 4 types of traffic. And so to illustrate the point, if you look at the middle slice, there is 2 types of traffic going there. So it can be IP address 2 and 3 for app number 2 and app number 5, as well as a URLLC slice, and they may have different destinations. But the way they are encapsulated in that slice is the URLLC slice. So this is the low latency applications. So that's how slicing helps separate the data and its priority and its delivery. And then just to complete the picture, the bottom one shows that there's only one type of traffic for each slice and there's only one application running on it. So it's basically illustrating the flexibility available once you know that you can slice up the network any which way you want. So this is basically the same picture shown in a more zoomed in picture. but nothing different here. It's just showing that per data network, you have a single slice. So in the standard, there is multiple different ways of actually implementing it, and it's all done in software. So it's easy to dynamically change. And the picture here is showing you the messages that go between the different entities in the network. So basically, you have so DNN is the data network name. This is the new name for APN in 5G network slicing. So you have the IMS DNN, and then you have the internet DNN, and then you have the user plane DNN. And within each of those, you have the blue boxes, which is the actual slices, and then they exchange messages back and forth saying, I'm a slice, I'm of type 1, 2, 3, or 4, depending on what's established. And then the connection is made, and then the service layer basically gets established, gets instantiated, and then the user starts getting served from the data. So that's basically 5G network slicing in a very quick nutshell. There's a lot more behind it, which you can tap into the resources section for. And I will hand it back to Stan to basically now talk about the usefulness of network slicing. Why do it?
Thanks, Safi. The current prevailing use case is really around broadcast TV. So it enables broadcasters to bring, the rich content. So think of somebody on the field at the Olympics or a major sporting event, broadcasting live and having a dedicated, their own dedicated slice that gives them that ultra low latency and rich content capability. You no longer need to have a very complex web of people in the background that are helping to broadcast that information out into people's homes. You don't need a satellite uplink. This is all delivered directly from the actual camera or a box attached to the camera. And this now enables it transcends the major network operators like an ABC or CBS kind of broadcaster, and enables people to be able to do the same kind of reporting, but down to a more regional level. So you could have regional sporting events or podcasters or live news broadcasters, which are oftentimes the actual reporter that is doing the camera themselves. So, and of course, influencers and semi-professional vloggers, things of that nature. So it really extends out the capabilities for people to be able to provide live broadcast out into the world. Other use cases will include applications that are focused on ultra low latency, as Safi talked about, things like drones or V2X or remote surgery, which is, that is something that is becoming more of a desire, is that ability to provide surgery in remote locations. Network slicing delivers rich content over dedicated segments. So Telefonica has launched a service offering dedicated slices to users or businesses. And essentially think of it this way: is each user receives their own portion of the SA network, and it guarantees them consistent performance. So they have a service level agreement, and they have that even in high demand environments like a sporting event or a congested building. They have they have very secure and very consistent performance. And as I mentioned, in terms of the actual broadcast video use case, there's really no need for a remote broadcast vehicle. Thin production team is which reduces cost, and remote workers remain secure to the corporate network with enhanced speed. So that really rounds out the what are the use cases and what are the benefits of using of network slicing to both the network provider as well as the user community. And I think that ends my portion.
Thank you, Stan. I think we hand it back to Amanda.
Yep. Thanks, guys. Audience, just real quick, I am going to drop a poll here on your screen. As Safi and Stan mentioned, this was really just a high-level view of some of these topics. So if you'd like to have one of our experts contact you directly, you guys can speak one-on-one. Please just respond here on the poll and we'll have someone reach out to you. Although we're not taking any live questions today, do feel free to submit using the box at the bottom of your screen here. We'll absolutely have someone follow up with you after our presentation here today. Safi, Stan, again, just want to thank you for your time today, and thank you everybody who joined us.
Yeah,
My
thank
pleasure.
you very much. Yep.
Thank you.
Thanks, guys.